So this is the from the sample final, number 15. Okay. So this is a nice problem about an ordinary differential equation. It says the rate of change in the number of squirrels, so the number of squirrels at time t is S of t, is directly proportional to 60 minus S of t. So the rate of change is the derivative, and to say it's directly proportional to something means it's some constant k times 60 minus S of t. So this says, this is rate of change of S of t, and this means directly proportional, and the proportionality constant is k, to 60 minus S of t. So this is an equation where the unknown that we have to figure out is the function S of t. It's a differential equation because it involves the derivative. And one technique that we have, almost the only technique, is separation of variables. So let me rewrite this as follows. Instead of ds dt is k times 60 minus s, s is S of t, I'm going to write this as 1 over 60 minus s, ds dt equals k. And then I'm going to integrate with respect to t. So what we have on the right, of course, the integral of k dt, that's just kt plus a constant. And what is this? This is on the left-hand side, it's 1 over 60 minus s ds. Like these cancel if you like, which is minus the log of 60 minus s. So minus the log of 60 minus s is kt plus some constant, I'll call it c1, which means 60 minus s is e to the minus kt, the minus sign, minus c1, or e to the minus c1, e to the minus kt. This is just some positive constant. And this is plus or minus 60 minus s. So what we understand from the differential equation is that 60 minus s is some constant times e to the minus kt. So I'm looking at the chat if you have any questions, but so let's just rewrite this. So s is 60 minus c e to the minus kt. So we have two unknown constants, the c and the k. But we're also given two bits of information. At t equals 0, s, the population at time 0, is 20, and we're told that 2 years later, s of 2 is equal to 50. So what does this condition say? So this is s of t. So if you put in t equals 0, you get 20 is f of 0 is 60 minus e minus c, e to the 0, which is 60 minus c, which means c is 40. So this s of t is actually 60 minus 40 e to the minus kt. And we can find k because we have a second piece of information. At 2 years, S of 2 is 50, which is 60 minus 40 e to the minus k times 2k. So what that says is that 40 e to the minus 2k equals 10, or e to the minus 2k equals a fourth, which means (2k) equals log 4, which is 2 log 2. So k is equal to log 2. So that S of t is 60 minus c. C is 40 e to the minus log 2 times t. E to the log 2 is 2. So e to the minus log 2 is a half. So this is 60 minus 40, 1/2 to the t. That's our function. Let's just check. When t is 0, you get 60 minus 40 is 20. When t is 1, you get, this is a half, you get 60 minus, oops, something is wrong. Sorry, that's right. When t is 2, 1/2 squared is a fourth of 40 is 10. You get 60 minus 10 is 50. So what is the answer to the problem? S of 3 is 60 minus 1/2 cubed times 40. So that's 60 minus 40 times an eighth, which is 60 minus 5, or 55. So the answer is 55. So chapter 6, 1 to 17 odd. So this is section 6.3, say number 15. We have the following differential equation: y prime minus 2e to the x equals 0. And we have an initial condition, y of 0 equals 3. So this is the ordinary differential equation. And we want to separate the variables. We want to have all the y's on one side on the left and all the x's on the right. So we could just write this as y prime equals 2e to the x. Or I can write this as y dy dx is 2e to the x. Or the way the book likes to write it is y dy is 2e to the x dx. And we integrate. And the integral of y is a half y squared. And the integral of 2e to the x is 2e to the x plus a constant. So what we get is that y squared is 4e to the x plus 2 times the constant, which is just another constant. So y is plus or minus the square root of 4e to the x plus c. So if this is correct, this is the general solution to the differential equation. Let's just check. What does it mean to check? It means plug this into the differential equation. If this is y, what is dy dx? Plus or minus, this is 4e to the x plus c to the 1/2. You get 1/2, 1 over the square root of 4e to the x plus c, times the derivative of 4e to the x plus c, which is 4e to the x. So this is 2e to the x plus or minus over the square root of 4e to the x plus c. Of course, this is just y. This is 2e to the x plus or minus this. This is my y. So what we get is y dy dx equals 2e to the x. So that's exactly this. It checks. So this is correctly the general solution of the equation. Now we look at the initial condition. From the initial condition, we can determine what the constant has to be. So there will only be one choice of a constant which satisfies the initial condition. So at x equals 0, y of 0 is 3, is plus or minus the square root of 4e to the 0 plus c. So e to the 0 is 1. So 3 is plus or minus, it's going to have to be plus, the square root of 4 plus c. So 9 equals 4 plus c, so c equals 5. So the answer to the problem is y equals the square root of 4e to the x plus 5. So this is the only function which satisfies both the differential equation and the initial condition that at x equals 0, square root of 9 is 3. Well, in this case, the general solution is this. But the only solution which is going to give you the value of 3 when x equals 0 is plus. I mean, for example, if y of 0, if the initial condition were -3, then y equals minus the square root of 4e to the x plus 5 would have been the solution. But it depends on the initial condition. See. Should I do one more? Okay. So this is 6.3, number 17. Number 17 is y times x plus 1 plus y prime equals 0. So again, I want to do a little bit of high school algebra to separate the variables. So the y's are on the left and the x's are on the right. So I could say, first of all, let's see, y prime is minus y times x plus 1. But I don't want the y on this side, I want it over here. So I divide 1 over y prime, or dy dx, is minus x plus 1. And now the variables are separated. I can write 1 over y is minus x plus 1 dx. Over here, they're just y's. Over here, they're just x's. And we integrate. So this is just the log of the absolute value of y. And this is minus the integral of x plus 1 is a half x squared plus x plus a constant. So the absolute value of, well, actually, let me just leave it like that for a moment. Let me see if I can figure out, now I also have an initial condition. So the initial condition is y at minus 2 is equal to 1. So what happens here if I put in negative 2? I get, so at x equal negative 2, the log of the absolute value of y is the log of 1, which is 0, is equal to minus 1/2 x squared, that's 4, plus x, which is minus 2, plus c, this is 0. So I get 0 equals 0 plus c, which means c is equal to 0. So the log of y is minus 1/2 x squared plus x, or absolute value of y is e to the minus 1/2 x squared plus x. Let's see. Oops. I didn't write this down correctly. It's e to the minus, so this is minus 1/2 x squared plus x. So this is e to the minus 1/2 x squared minus x. And in here, just to double check, when I put in negative 2, I get 4. So I get minus 2 plus 2, e to the 0 is 1. So, and this is always positive. So y, you can write e as minus 1/2 x squared minus x. Oops. That's the solution.